Hello guys, welcome to another video, and today we will be having a quick summary about the chapter 7, which is the IP addressing. So first part, we have IPv4 network addresses, binary and decimal conversion, binary numbers versus decimal numbers. Binary is a number system that consists of numbers 0 and 1 called bits. In contrast, the decimal numbering system consists of 10 digits consisting of numbers 0 to 9. Binary is important for us to understand because all service networks use binary addressing. So binary it means that they are a combination of ones and zeros, and also it is how it is used by the computer, a device, to act as a instruction on what it can do or what we want the device to do. And of course, it is very important for our addresses, most especially in the network industry. IPv4 address structure. The IP address gives a device a unique address over a network. The subnet mask used to identify the network and host portion of an IPv4 address. The ones identify the network portion of this and the zeros the host portion. So as we can see here at the subnet mask here, we have all ones in the 255.255 and 0 we have all the zeros. So the ones on each octets are the network portion, while this is the host version. IPv4 networks host and broadcast given a 10.1.1.0/24. So it has network address 10.1.1.0, first host address 10.1.1.1, and last host address is 10.1.1.254, and the broadcast address as 10.1.1.255. Normally in practice, the first host address is the default gateway address. In this case, the default gateway is 10.1.1.1. So here we have two addresses, the first host address and the last host address. So we have here the binary representation, and here first we have the 10.1.1.1. Well, the last host address is the 10.1.1.254. So for the host portion we have here, we will be getting the host address, which is the last number to the address, and then we can determine the value by looking at the positional value for the binary. IPv4 unicast broadcast and multicast. IPv4 communication, unicast send packets from one host to an individual host. Broadcast send packets from one host to all the hosts in the network. Multicast send a packet from one host to a selected group of hosts in the same or different network. 224.0.0.239.255.255.255 IPv4 addresses are multicast range. 224.0.0.0 to 224.0.0.255 multicast for local only. Which types of communication are the graphics on the right? Types of IPv4 addresses. So we have public and private IPv4 addresses. Public IPv4 addresses are addresses which are globally routed between ISP or Internet Service Provider routers. Private addresses are not routed over the Internet. Private addresses examples are 10 that the ones that start with 10, starts with 172, and starts with 192. Special user IPv4 addresses. We have the lookback addresses, which is the 127.0.0.0. For the link local addresses, we have 169.254. For the testnet, we have 192.0.2.0. IPv6 network addresses. The need for IPv6. Division of IPv4 address space. Internet of Everything. The evolving internet is becoming an Internet of Things. No longer will the only device accessing the Internet be computer establishers, not processor equipped. Internet-ready devices from tomorrow will include everything from automobiles and biomedical devices. It also applies to natural ecosystems. Unlike IPv4, which 32 bits, IPv6 is 1 to 8 bits. IPv4 is approximately 4.2 billion IP addresses, but IPv6 is 340 anticillion, 340 followed by 36 zeros addresses, so that's kind of big. IPv4 and IPv6 coexistence. Dual stack allows IPv4 and IPv6 to coexist in the same network segment. Dual stack devices run both IPv4 and IPv6 protocol stacks simultaneously. Tunneling, we have IPv6 packets encapsulated inside IPv4 packets. Translation, IPv6 packet is translated to an IPv4 packet and vice versa. IPv6 prefix length, we have indicates the network version. IPv6 address slash prefix length. Prefix length range from 0 to 128. Typical length is /64. We have these common types of IPv6 addresses. The global unicast addresses, similar to IPv4 public IP address, unique internet routable addresses, configured statically or assigned dynamically. They are in the range of 2000 to 3FFF for the meantime. The local unicast addresses communicate with other IPv6 enabled devices on the same link or subnet. They are confined to a single link. They are not routable unlike GUA. Device creates its own link local address without the HTTP server. Unique local addresses, unique local unicast allow similar to IPv4 private IP addresses used for local addresses within a site or between a limited number of sites. They are in the range of FC00 to FDFF. Link local unicast addresses communicate with the other IPv6 enabled device on the same link or subnet. They're confined to a single link. They are not routable unlike GUA. Every IPv6 enabled network interface is required to have a link local address even if it does not have a GUA. Devices create its own linked local address without the HTTP server. IPv6 linked local addresses are in the FE8010 range. The 10 indicates the first 10 bits are the first extent has a range of 111 1110 1000. IPv6 unicast addresses. Structure of an IPv6 global unicast address. The global routing prefix. The global routing prefix is a prefix or network portion of the address that is assigned by the provider such as an ISP to a customer to our site. Typically, RIRs assign a 48 global routing prefix to customers. Global routing prefix subnet ID. The subnet ID is used by an organization to identify subnets within site. The larger subnet ID, the more subnets available. IPv6 interface ID is equivalent to the host portion of the IPv4 address. The term interface ID is used because the single host may have multiple interfaces, each having one or more IPv6 addresses. It is highly recommended. For a stateless address auto-configuration, is a method that allows a device to obtain its prefix length, default gateway address, and other information from an IPv6 router without the use of a DHCPv6 server. Using SLAAC, devices rely on the local router's ICMP router advertisement messages to obtain the necessary information. It's a method that allows a device to obtain its prefix and default gateway address and other information from an IPv6 router without use of a DHCP-basic server. Using SLAAC, device rely on local router's ICMPv6 router management messages to obtain the necessary information. IPv6 routers periodically send out be sent in response to a host sending an ICMPv6 router solicitation or RS message. ICMPv6 ICMPv6 RA message is a suggestion to a device on how to obtain an IPv6 local global unique address. The device's operating system. The ICMPv6 RA message. Network prefix and prefix length. Tells the device to which network it belongs. Three options for RA messages. Option 1. By default, the RA message suggests that the receiving device should the information in the RA message. 6 global unique messages. Option 2 SLAAC and stateless DHCPv6. In this option, the RA message suggests devices should use SLAAC to create its own IPv6 local unique address. The router's link local address, the RA source IPv6 address for the default gateway address. A stateless DHCPv6 server to obtain the other information such as DNS. With this opinion, the RA message students devices use SLAAC to create its own IPv6 global unique address. The local router address to a source IPv6 address for the option 3 stateful DHCP-v6. Stateful DHCP-v6 is similar to DHCP5-BB4. Device cannot together receive its blessing. Information including global unique address prefix length and the address of DNS. Stateful DHCP-v6 similar to DHCP5-BB4. It's just the same as D1. IPv6 multicast addresses. Assign IPv6 multicast addresses. Then the prefix 8. IPv6 multicast addresses have a prefix ICMPv4 and ICMPv6. ICMPv4 and ICMPv6 whose confirmation, destination, or service unreachable time exceeded router redirection. ICMPv6 router solicitation router advertisement messages. Messaging between an IPv6 router and the testing and verification. We have here the two commands. The ping that tries to route. So you can connect to the local LAN or the remote when it is using the ping command. For trace route, they will test the path available for the trip of the segment or the packet. So the summary for this is explain the use of IPv4 addresses to provide connectivity in a small to medium size business network. Figure IPv6 addresses to provide connectivity in small to medium size business networks. Use common testing utilities to verify network connectivity. So for the first bullet, we know that the IPv4 will soon be changed with the IPv6, but still we need to maintain the road and good. That's it for my chapter 7 summary, and thank you for watching, and I hope, and please leave a like to my videos, and thank you and goodbye again.